Thank you, guys. It's great to be here. Let's get started. It's really one of my favorite conferences. I like we have such a relaxed, laid-back community where we can discuss content and ideas about predictive APIs. So I work at ING. It's a bank. The one with the orange lion. So I apologize for the tremendous amount of orange I've used in the slides. Sorry, I hope you can cope with it. So it's ING actually is a group organization. It's located in more than 40 countries, and if you count all the amount of customers, SMEs, individuals, corporate, etc., we have more than 33 million customers worldwide. And organization-wise, it's a massive organization. It's 50,000 employees plus. So at ING, I think that the way why I like so much to be here is because actually the motto, the slogan of ING is to empower people to stay a step ahead in life and business. And in a way, this is actually the ultimate sort of predictive slogan. In a sense, you want to help the customer to be there and to make informed decisions about their finances and their financial life. So, taking that sort of idea, I would like to bring back a little bit of, let's say, a psychology class and an idea back from the 60s and the 50s. One of those guys was very strong in that period was a psychologist called Maslow, who actually became famous for a theory which I think somehow applies still today, that we as people, we actually have a certain pyramid of needs. In a way, what happens is that when we were back in the prehistoric period, then we were living in caves, so our main concern was to gather food, to hunt for dinosaurs, and to keep ourselves warm in those caves. But as far as we proceed in our evolution, you see that actually those needs, you start to take it from granted. So you have a house, a place where you feel comfortable, and then you evolve into other needs. You start thinking of, let's say, resources, health, property. So, for instance, you would like to stay healthy, and you would like to have water or electricity as a utility. That's why we call them utilities, right? And if you move up, and if you have all this, and if you have some form of securities, a house, resources, maybe a job would be nice, then you can move up another layer, and then you see that your needs become more, let's say, abstract, more related to what we are as individuals in a community. So you start caring for love and affection, for family, for friends. Say, okay, the typical things that you hear most these days is like, I would like to spend more time with my friends. I would like to combine better my work and my private life, etc. And if you move on and on, then you see that this becomes, again, a way to evolve into bigger projects, to mean something in this planet, right? As Steve Jobs used to say, to put a bit of a dent in the universe. And creativity, freedom, helping others is actually also something where you might feel as a need to be an accomplished person in life. So why I'm telling you all this is because actually think of APIs, and you could actually imagine that APIs, they are a tool, right? So unlike all those tools, we build them because we believe that we can actually fulfill our needs better with a couple of tools. A house is a tool, as well as, for instance, a social network is a tool, right? So APIs are actually also a tool, and you could plot those APIs also in the same sort of pyramid. So if you actually take the basic API and say, what's in there? Well, it's a little bit of, let's say, electricity, and there is a protocol, and that's, I would say, a pretty much, let's say, basic level. Then you might actually start to expose resources, like, for instance, transactions, and you would have, let's say, a bit of a more evolved APIs. Then you move up, and those APIs, they start to be, let's say, interacting with you. For instance, providing you notification. You might actually seek for APIs that autofill or autocorrect your digital life when you fill forms, for instance. Maybe a little bit of recommenders that actually help you out selecting a movie or selecting your playlist on Spotify, etc. And then we come to a kind of a, let's say, pretty much bleeding edge in the domain of API design. Those APIs, they tend to become more, let's say, a companion tool for you to actually perform your function in life, like, for instance, predicting and planning, set goals, provide achievement. Well, of course, I mean, if your achievement is a Candy Crush Saga, then of course it doesn't not that useful, but think also, for instance, mortgages, or these are financial achievements that, and there might be APIs, and we have seen in the last period APIs that actually kind of simplify that process. So all this means that APIs are tools, and as tools they have various degree of evolution. Which brings back to the I would say the main topic of this conference is that when actually you are dealing with predictive analytics or with predictive APIs, you have to realize that all exists because there is data. And data is, in a way, the fabric of our lives. We perspire data. We consume data, and we produce data at every single moment in our life. And most of this data actually is digital these days. And I would say that every single relation and relationship that you have with either other people or tools or organization is basically a relationship based on data, memories, information, transactions, right? So, if you go online and if you check and if you type data is the new, then you get all these pre-filled answers by Google, so it's Google, so it should be right. And we get data is the new oil, is the new soil, the new bacon. I think that makes sense. So, well, actually, to me, in a way, I have to disagree with all of those, let's say, definitions, because I don't think they really touch on the essence of data. And data for me is, I would like to see data as a relationship. And being a relationship between two parties or more parties, there are a number of characteristics of this relationship that really need to be nailed down and need to be actually protected and exposed and validated. And things like, for instance, trust, transparency of views, why I'm using this data, respect and protect. So if you heard about all the story with Apple and the American government, it's a battle about regulations, laws, and respect and protect, and this interaction and this relationship between a customer and companies. I think this is very important, And if you see data as a relationship, then you understand that when you have a customer, it's nice to put the customer first. And when the customer is first, then you're providing a service. In a way, the best services out there is where you first make your customer thrive rather than make the company thrive. So in that relationship, then in a way, you could see data as a sort of an, let's say, common background between you and your customer. And in a way, this provides you a very ethical way of looking at data. Once that you have that in place, then you realize that if I'm doing actionable data and actually want to transform my data into actions, then in fact it boils down to two things. Either you help the customer, so you propose, advise, select, filter, connect, simplify the life of the customer, or you protect the customer. So you detect, you alert, you block, you verify the identity, you authorize the customer to perform some operation or others. So I think that actually this slide contains, I would say, almost 99% of all possible predictive analytics that you would ever need. Because either you help the customer or you protect the customer. So at ING we have a number of initiatives with that respect. So for instance, on the side of, let's say, speeding up and simplifying the process, we are partnered up with a number of companies like Cabbage and WeLab. And some of those are actually tested in these countries, in ING Direct Spain, as a way to extract, let's say, sufficient information and context in order to actually enable a loan within minutes rather than in days. Also, another initiative started in Spain and now executed as well in Poland is to help the customer simplifying the bank experience. If you actually have transactions, why those transactions couldn't be exposed and presented in a way which is more intuitive for the customer. And there we have, for instance, a new interface which is based on defining goals, defining a clearer and a smaller context, for instance, with a number of voices, how the let's say the monthly expenses are categorized in a couple of categories. So you might say, okay, where is actually the predictive part into this? I'm actually think that there is a lot of potential for predictive analytics if you look at banking in particular in this way, but it's not all realized, absolutely not. So there is so much more than can be done. And talking from, let's say, the perspective of a bank, I would say that we are just started. And I look forward to what we as a community we can do about predictive analytics if you actually look at this. And of course, big kudos for the Spanish team that actually have realized that. So let me take one step back and talk now a bit about data science, right? Because data science is important, and we understand that if we want to have meaningful interaction, we need good data science, right? So this actually is, I took over from Joshua Benshaw, which is one of my heroes in the data drive, in machine learning world. Is one of the founder of the let's say the Deep Learning Institute, and is working a long time with Jeff Hinton on hierarchical neural networks. So there are a couple of phases that you are living in data science and machine learning. So up to, let's say, a few decades back, but I would say even today, most of our work was in hand-designed program. I mean, you need to identify, for instance, pedestrian recognition for automotive. Then you write a program that it's custom-made, and the feature and the execution of that model is actually in that program. If you look at lots of marketing strategies, they actually rely on rules. And those rules, they come from a sort of a gut feeling of people being working in that domain for a long time. And they actually believe that you should target one segment in a certain way rather than another. It's all custom made, it's all custom written for that specific goal. What we are experiencing now today is mostly this column here. We are actually, what we call it here, apologies for the kind of a bit condescending, but it's a classic machine learning approach. And why is it classic? Because we still have this heavy task of hand designing our features. Why is this so? Why is that good and why is that not that good at the same time? Well, first of all, it is better to just design the feature and have a machine learning algorithm to help us defining, for instance, the classification problem or the clustering problem, like Louis has very clearly explained this morning. However, you rely on features. And if you handwrite your features, then you might actually pick up the wrong ones. And if you do so, then your machine learning is not that powerful after all. What we are seeing is that in some domains, there is a bit of an evolution going into the direction of automatic feature extraction based on what people in the academia called embeddings. I don't know if that word rings a bell. It's basically the idea that our data, because it's not random, it actually has some patterns, lives in some sort of subspaces within those, let's say, 600 features that you have generated and created. And those subspaces, they have a much smaller dimension. However, those subspaces, they're not necessarily linear. So they might have specific shapes that you might not detect at first. That's why sometimes, let's say, mapping feature in this column fails to find the right subspace. There are a number of techniques here that they go under the name of representational machine learning, especially the representational distributed machine learning, which try to warp the space where this actually data lives in order to interpret and understand the domain. So in a way, it's the very basic idea of learning a domain is to understand how the data points in this domain are related. And that's what we with our brain do when we actually go on, for instance, on a mortgage website, comparison website, or on a website that compares real estate. So we actually try to figure out all those columns of values like the area of the real estate, the number of rooms, etc., and try to project a mental map which might not necessarily be linear. We know, for instance, that things in the city center they have more value than things in the suburbs and so forth, but maybe the relation is even more, let's say, involuted. Latest, we have seen that if you take this one level farther, you realize that once that you have these features, you actually can apply one extra trick, and the trick is called hierarchy. So you could have actually features describing features. Now that thing is called deep learning, and it's all over the places now because it's becoming, let's say, an interesting way how to give a machine the possibility to learn without having to explain what that system is about. So I don't know if you followed AlphaGo or for instance, DeepMind at Google, where they actually they have a neural network playing a game, an Atari game or a Nintendo game, I don't remember, but actually a game where the only thing that they told the computer program was, this is how you have to keep track of points. That's all. And then the game and the computer program try to figure out how to play Arkanoid, which is a complex task, right? Back to, so this part is like science fiction for most of us. And this one is what we normally do. We try to, with some pain and some meetings, to move people from having their gut feeling translated into a classic machine learning with a couple of well-crafted and well-generated features. So, if you look at predictive APIs in banking, it's actually a pretty long journey, if you look at it from this perspective. And it's a long journey because actually you're embarking in AI, and AI is still, I would say, a pretty big deal. So, in fact, how do you get there? I think that the best way to get there is to be humble a bit and take one step back and understand, okay, I have some data, and now I know that Google with AlphaGo can beat the world champion of Go, but let's take it lean and one step at a time. Which means that let's have a look at the tools available. Boosted gradient descent, very good tool. A random forest, very good tool. SVMs, decision trees. These are all fine tools, KNNs. We have libraries. We have APIs. If you actually want to use APIs, you can tap on the API economy. You don't have to rewrite it all yourself. We have scientists and engineers that can actually help out when the tool falls a bit short or you need a bit of glue between technology and science. And you have domain experts. Why not? I mean, they're also part of the mix. If there is a guy that knows a lot about, for instance, fraud or cybersecurity, sure, why not exploit that knowledge and build and jumpstart the feature selection, for instance. It's absolutely valid. So if you ask managers about that, and then you ask, what shall we do today? Then you get usually this sort of answer. Choose them all. Why actually choosing just one? Well, that's the problem, is that if you want to choose them all, even for big organizations, it might not be doable. I mean, there are just so many alternatives these days, both in the arena of, let's say, fintech companies, as machine learning startups, as tools and libraries, that it's simply not doable anymore. So I think that what you really need to do is actually to kind of wrap it up and make some choices that reduce a bit the scope of what's possible, because what's possible might not be feasible today. There are just too many choices. Couple of things that we are doing concretely, for instance, is looking at geographical pattern using density algorithms to understand how to cluster in an unsupervised way in information and transaction, looking also at possible scenarios for marketing and fraud and cybersecurity. There is an article on O'Reilly if you want to read from it. We also have another presentation coming up at Stratton Hadoop, which is in a few weeks from now. for real-time fraud detection using process mining, trying to understand what is a legitimate path, for instance, in the website and what is not, and how to actually understand LT or common versus uncommon use of a website by looking straight into the data. And that's a lot, it's happening, and we have these data science teams, and they're all very enthusiastic, and they all want to do great things, and they read about these Netflix competitions, and they read about these immensely complex models of 1 million parameters and so forth. And let's put it this way, sometimes they get a bit overexcited. So if you get a couple of data scientists in the room, I guess, and when you talk about your models, probably you think something like that, right? Like SVM, no, it's random forest. Ah. Yeah, I mean, of course, yeah, it's really good, and it's great to talk about models and ideas and neural networks and so forth. But let me tell you the other part of the story. This is how managers look at data scientists talking about models. They say, nah, yeah, you know, SVM, okay, random forest, who cares? Like, yeah, they play, they're cute. Have some more. Let's say another 2-1. So the main reason why this is happening, and at the beginning I was shocked. I said, oh my God, this cannot be. I mean, all this good stuff and mathematics, and they don't get it. But the reality is that data science must deliver an outcome. And an outcome means that some manager must see something happening in the organization. And so the main thing is not delivering a new model, but is understanding how can you quantify the quality of your model. Can you identify the impact in your organization of that model? Eventually, it would be even better if actually you would say, these models translate into so much more revenues. This is the return of investment of that model, right? So if you actually would have that magic formula, we will all be much happier. And maybe you would have also a bit more, let's say, realistic and responsible way of providing models and APIs and building companies around machine learning. Because once you're, let's say, faced with the outcome, well, then there is no much room for, for dodging the ball. You really need to make it happen. Unfortunately, what we see today is that there is no such an easy formula. And you might actually see that some companies that have APIs around predictive analytics or text detection or sentiment analysis, they do not have a clear and way of determining quality. And that at the end, in a way, hurts us all, because how can you make a choice between two companies? One has twice as the value of the other, or maybe the fee or the license scheme is way more expensive, but is actually the quality way better? These are actually questions which are largely today, they are unanswered. So we talk a lot about algorithms and models, we don't talk that much about quality. And I think this is when data science will become more mature. I think this is something where we will all be tending to look at in the coming years. Since this is a sort of a keynote speech, and I would like to give you a bit of, let's say, a couple of inspiration of mine, which are not ING related. One of them, for instance, is Level Money, which was recently acquired by Capital One, where actually they provide an indication of how much money you can spend in a day or in a week or in a month. It is not necessarily that they actually claim that this is what you can spend, but it's more of an indication. So even there, you need to be very careful exactly what do you mean by being predictive. What is your accuracy? What is the quality that you provide? Am I actually allowed to spend only 20 euros a day or 30 euros? Where is this information coming from, etc.? I think that this application, they have a given value, but you have to be very precise and explain well exactly what do you mean by that. Another one, again, an inspiration from the web, is a company called Plaid, which is basically it's mostly an American, operating the American market. And they actually provide API from banking data on two different levels. You remember the Maslow law. So those two levels are actually transactions on the lowest level and risk scoring on a higher level. So it's again a nice visualization how this psychologist sort of pyramid of need actually applies here. You could go for the transaction where you would have, for instance, machine learning embedded. Think, for instance, about auto classification of transaction, where you don't need to specify actually the label for this transaction. For instance, is that food related or non-food related? As well as, for instance, an higher level, which is providing actually an indication about how you're doing financially. Is that a scoring available for you in case you would like to go for loans, or you want to go for credit card form application and so forth. So opportunities, I will go a bit faster here, but please look at the slide later. They will be available at a certain point. Feature extraction, anomaly, novelty detection. I think this is a domain where actually we'll see more and more coming up. Things like graph analysis, as well what I call this nonlinear manifold sort of structures. These are actually, seems like sort of Star Trek talk, but actually they do apply quite well, especially in domains like fraud and cybersecurity. Space embeddings, mixture of semi-supervised sort of ideas like classification plus clustering. These are also becoming quite interesting. We don't see classification and clustering anymore as two separate things. We see more, let's say, scenarios where actually the classification helps the clustering and vice versa. This is, for instance, an analysis of Netflix movies based on a number of features, trying to collect the features, to collect movies of the same type. So, for instance, I don't know, anime would be here, and French movies here, and horror there, etc. So this is a nice idea how to do that. And not to forget, I would say voice, speech, and video recognition. This is also a very important one, since it enables one thing which is called zero UI. And zero UI, if you have seen the movie Her, I think it's a pretty cool thing. Even, of course, it's even more cool if you have Scarlett Johansson talking, but even if she's not talking and you might actually have at zero UI, I think it's still cool because it's the elevating the interface to a human level sort of communication. And you would do that both in text, emailing, messaging, video, speech, etc. I think it's a fantastic opportunity there. So, to summarize, I would say this picture says it all. you could have the API is like the rail, but then the rail without the boards, I would say it's not really great. I mean, because you need some data and some science where you need to walk on. And that's, in a way, the way I look at predictive APIs. You need ease of use, which is provided by APIs, but you need to have those APIs actually doing something useful. And the usefulness would be basically provide the right data, provide the right science, so that you can transform your technology into an amazing experience. And with this one, I would like to thank you all for the time here.